Hi, my name is Dave. My online name is Dave Make Stuff, and I make a lot of stuff with nTop. And today I wanted to show you my design process for this cool little fir tree. Given the season, I've changed it into a Christmas tree. So you can see it's quite detailed, all the needle points and branches, and taking a look from underneath there, you can see that it's branches all the way up. So just in summary, we're going to be talking about points and working with large lists of points, and then the branching lattice feature in nTopology. I'll also talk a little bit about one of the custom blocks that I used to make the graphs behind this, and how I distributed the little ornaments on the trees. First, I just wanted to show you here a little bit what it looks like when it's 3D printed. A lot of the projects I do are for desktop printing community, and so these are printed in resin, and the tiny little needles there are 0.5 millimeters. And and then the trunk goes back. These are about 1.5 millimeters in the printed version. Anyways, I just wanted to give you a view of what that looked like. If you haven't heard of nTop, I encourage you to take a look at the website. nTop is a design software for high-end engineering applications, so a lot of lightweighting, topology optimization, and things like that. Fascinating program. I use it a lot for arts and creative purposes. And Topology also has a community platform here. So this file that I will be going through and any related resources will be posted here on the nTop community platform. If you have access to that, you can download anything that I'll be going through today. If you don't have access to nTopology and just want to download the STL files for 3D printing, I have uploaded them to Thangs, and my link for that is in below. So let's dig in here and talk a little bit about how this tree was designed. So first, I think what I'm going to do is I'm just going to turn off the ornaments. I'm going to turn off the full tree there, and we're just going to go right up to the very top here. So this top list here is just full of all the variables that is used to make up the tree. So the first two variables, the height of the tree and the angle of the overall form of the tree, just makes a cone. So that's a simple process there. And what this cone becomes is where so every needle tip corresponds to a point map that we'll come to in a few minutes, and all of those points are pulled to the surface of this form. So if I was just to use a straight cone like this, the tree would have very straight edges. It would look more like an artificial tree. So if you'll notice up here, the next few variables are tree roughness frequency, tree roughness amplitude, and tree rough seed. So those, if you're familiar with nTopology, are just the inputs into the surface roughness block, surface frequency, amplitude, and the seed value for randomizing that surface. And if I show you what that looks like, it just creates a cone that's it's got a roughed up edge. So now when we put the points on the surface, it just gives the tree, the form, the outline of the tree a little bit more of a natural look. You can change those variables to make it rougher in various different ways, and but those are settings that I find work well. So coming down here, now we've got the form. Now what we're going to do is we're going to put here point count, which corresponds roughly to the number of needle tips on your entire tree. I've set to 4,500, which is reasonable for a tree of 80 millimeters. And we can take a look at that. And there's where all of the needle tips will branch out to. Now you can see this cone also has its generated points at the bottom, which we obviously want to get rid of and not have needle points going to that, but that comes a little bit later on, but just something to keep in mind. So actually, let me keep that on here because I wanted to. This is an interesting uh, approach to selecting out these different points and selecting which points join together to branches to go back to the trunk of the tree. And this isn't done just randomly, and the reason that that's not done randomly is in order to print this, especially with additive manufacturing, such as resin printing. Of course, all of the angles have to be below a certain point. You can't have this is printed suspended from the build plate from the tip of the tree here, so you can't have any branches. Obviously, you can't have them angling up. They all have to be angling down at about 30 degrees. So what that means is I can't have a branch that starts at the tree at this point and goes up to a tip over there. So this whole process here is all about selecting what branch tips, where those, or sorry, the needle tips, where those branches will originate from. So let's just dig into this block here, and you can see that this is a custom block, and I will put this custom block separately up on the nTopology community site. I've just named it trunk to needle tip graph. And so let me tell you what those parts are, and then I will explain how that works. So going up here to the top, right under point count is number of segments. So I've set that to 30. So what this does is divides this tree into 30 segments. And if I put those all together, it just looks like a single cylinder. But just to make things clear, I've pulled out the bottom cylinder and the top cylinder. And there's, of course, 28 different cylinders in there. Each of those is, the purpose of those is to select from this cone of points, to select out all of the points that lie within that layer of the cylinder there. So let me just hide those. So you can imagine I'm pulling out needle tips for this level here. And this right here is the branch origins. And you can see they're raised up. And that's done on purpose. That's just done through a sequence here. And the branch origin points right here, this variable called the bottom branch rise, that is the distance from the top of that cylinder to the branch origin point, where that branch is going to originate, that goes out to all those tips. So if that was set to, right now it's set to 5 millimeters, it's 5 millimeters higher. If that was set to 0, the branches would all orient at the same level as the branch tips. Then we'd of course run into that problem, 3D printing. The angles would be all wrong. So these two variables here, the bottom branch rise and the top branch rise, mean that the bottom branch rises up 5 millimeters, and at the top here, just because this cone is narrow at the top, the branch origin doesn't have to be as high above the needle tips in order to get the right angles. That is 1 millimeter up above, and then of course that's a sequence. So all of the height between the needle point and the branch origin is just spread out between those branch points there. So what we've got here, we've got the cylinders, we've got all the branch origin points, and now I can show you or talk a little bit about how this custom block here works. So how this custom block works, one of the inputs is all of these points. So all of the entire tree full of points. And then the branch origin. So that inputs a list of these branch origin points. And then the list of tip point filters. So there's and these lists have to correspond in terms of numbers. So there's 30 branch origin points and 30 tip filters. And what that does is it outputs, it creates using the up here under the in the architected, where am I going here? Lattices, conformal lattices, stochastic lattices, and this is uses the branched lattice block inside. For every segment, it is, you can see the point there, it's making a branched lattice from that branch origin point out to all of the needle tips there. And I do a lot of my custom blocks when I'm working with points and lattices and things. Use I often do have graphs as the output, just because it lets you, when you're running this custom block, you're running it with multiple branch origins and filters, and then you get out a list of graphs, and it's really just rich with information. You can pull out all the points and all the vertices and everything associated with those graphs. But they're really nice to work with because then I can merge them and I can put them through the lattice from graph block, and now you can see I'm getting my branches. So there's no trunk in there, but I'm getting all of my branches. You'll notice there's a little bit more to this lattice from graph block here, and that is because it's in this block where we thicken those graphs and we give them a little bit of substance. You can see that I'm using a ramp down here. Let's just go up here and take a look at the next few variables. So the branch thicken depth, the tip diameter, and the branch diameter are all variables that you'll see in here. And so what this is doing is it's ramping the thickness of these branches. I'm using the cone as the scalar field to modify it. So right at the margin of that cone at in minimum 0, I'm thickening that to the tip diameter. So this is set. Anything that's on the boundary of that cone, the thickness is going to be 0.5 millimeters. And then the branch thickening variable, which in this case goes 10 millimeters in. So in the space between 10 millimeters from the edge in, the thickness goes from 0.5 millimeters. And I think I've got the branch diameter set to 1 here. Let's just see, there's our branch diameter to 1 millimeter. So within the space of 10 millimeters, it goes from 0.5 to 1 millimeter thick here. So there, we've basically got our all of our branches. We don't have a trunk yet, so that's coming next here. Let's just scroll up here, and the trunk is just a fancy cone. Right here, the trunk bottom position. So that bottom position of the trunk, we want that to extend below the branches, of course. So this is going to go -5 millimeters. The trunk top radius at the very top, I've got that set to, where are we here? 0.2 millimeters. The bottom radius, the thickness of the trunk, is 2 millimeters, and then these next few things, because I've given a little bit of texture to the trunk, is the trunk frequency and the trunk amplitude at the top, because we don't want a huge amount of roughness at the very top. It's quite thin, but that's going to be graded to down at the bottom. The roughness of the amplitude of the trunk at the bottom is going to be 0.2 millimeters, and then here's just the variables related to the surface roughing, the seed, and all that. So you can poke around in that a little bit more, how I've set that up, and grading the surface of the trunk, creating the cone for the trunk. But basically it looks like that, nothing too fancy. At the bottom here, as I'm assembling it, let's just take a look at the assembled version here. And this is just one of those fascinating little details with nTopology, that when you're doing a Boolean function, and I'm merging all those branches with the trunk, and in that merge block, you can it's a rounded blend type, and you can put a scalar field, a ramp, into the blend radius. So here, where the trunk is thick and the branches are thicker, this blend radius here, let's go up to the top here, lower branch blend is 1 millimeter, but by the top of the tree, and the blend is essentially a fillet, a very complicated one. At the top of the tree here, that fillet, that blend between the trunk and the upper branches is just 0.2, because obviously if you put a big blend in there, it would just mess everything up. So that needs to be blended. So with that tree there, let's just take a look at the. This is kind of a neat way to look at it. Just doing a cross section view, and you can really see where the how the angles of the branches are. And I'm just curious here if we can see. Oh, okay, there we go. So there we've got. Now this is a really good image of how all that point selection works. So here you can see there's points all the way up along the surface of the cone. Taking a look at the bottom layer of branches here, so the bottom section, it selected out all those points just in that one layer, and all of those points branch up to that branch origin point there. In terms of how we've set up the branching block there. So that's a neat way to. That's just a neat way to view it, to image it. So in my in the STL upload on Thangs, I've only done the fir tree here. I haven't actually printed off a version with the ornaments in, but I thought, given that I'm making this tutorial in lead up to Christmas, why don't I stick some ornaments on there? It also gives an opportunity to talk about an interesting way that I use to select random points. So the position of these ornaments is all selected from that initial list of points. So let's just clean that off, and let's go up all the way to all of our points, which is there. So there's our full point list that created all the needle tips, and I've just randomly selected which points to put those ornaments on. And the way that is easiest to do that, if you just want a quick and dirty way of setting that up, is I actually use a simplex noise field, and let's just visualize that. So there's the simplex noise field, which is a field of values that permeates all of the design space. So I've got it set to a fairly high frequency, which means it's quite a dense noise field. And you can see, if you take a closer look up here, here's all of the values. I'll probe the points. The reddish ones there are negative values, and the cyan ones are positive values. So what this is doing when I use this with the filter points by volume block is it selects all of the points within the negative range here. So if this was an implicit, the values that are negative would be sort of your visual implicit body, and by using this random field to select out the points, I'm selecting any points that lie within those negative values. Now I've also, just to so I could iterate this, I've created a variable here that basically biases that simplex noise field to either include more or less of those negative values, and then in turn more of those ornaments. So you can see I've put it up to 0.4 and it selects a lot more of those points. So I just put that in there to make it a little easier to get the tree that I wanted. So let's wait for that to generate there. Oh, flash. Oh, that's why it took so long. What did I do here? So I accidentally put that up to 3. So basically it stuck an ornament on every single point, which is not what I wanted. I wanted it at 0.3. So let's let that cycle through. I'm going to hide those points and I'm going to go back on here and put the final tree up. And we can take one last look at it, and I'm going to say thank you very much for watching. I hope you've learned something. I hope you've perhaps learned how to make a tree, or perhaps you've learned a technique that will help make something that's more in your area of interest. I hope you enjoyed. Thanks again. Bye now.